Alright, so to start today's lesson, I want you to think about these questions for about 15 seconds and then turn and talk to your partner about what you remember about solving systems of equations, what methods you can use, and the types of solutions. Alright, now that you've had a second to talk about it with your partner, we are going to actually review solving systems of linear equations. So, our first method we're going to look at is graphing. You can solve a system of equations by graphing the equation. So usually this works best when both equations are given in slope-intercept form. So if you recall, that's y equals mx plus b, where m is your slope and b is your y-intercept. So looking at this picture here, we can see graphing is a very easy way to see the type of solutions, whether we have one solution where it intersects at one point, no solution where they're parallel and never intersect, or infinite solutions where they are the same line and intersect the entire way across. So let's start with an example of graphing. So we have the system of equations y equals 2x minus 3 and y equals negative 2/3 x plus 5. So starting with y equals 2x minus 3, my y-intercept is at the point negative 3. And my slope is 2, which means 2 over 1, so my rise I'm going up 2 and run is 1. So I'm going to connect these and do my best to keep that slope steady there. Okay, and then my second equation, I'm going to use a different color here. Y equals negative 2/3 x plus 5. My y-intercept is at the point positive 5. And my slope is negative 2 over 3, so I'm going down 2 and to the right 3. So when I connect my dots, I can already kind of see where that solution is. It goes through this point right here, which remember points are written as x, y. So for this one, that is 3, 3. Okay, our next method that we're going to review is substitution. Substitution works best when the equation is already in the form y equals or x equals, because then you can just substitute the value for y or x into the other equation. If it is not already in y equals or x equals, then you have to solve for y or x to be able to do this method. So for this example, the reason I gave this one to you is because it already has y equals in the first equation, but they are not both in slope-intercept form, so graphing is not the best one to use here. So when we work with substitution, y equals 2x minus 1 and 2x plus 3y equals negative 7, I'm taking what y equals and I'm substituting it in for y in the second equation, which means I have 2x plus 3. I'm replacing y with 2x minus 1, and that equals negative 7. Then I'm just going to solve this equation for x. So first thing, I distribute. So 2x plus 6x minus 3 equals negative 7. I combine like terms. 2x plus 6x is 8x. Minus 3 equals negative 7 still. And then I use inverse operations. So I'm going to add 3 to both sides. which tells me 8x equals negative 4. And then divide both sides by 8. So we find that x equals negative 1/2. I'm not done yet though, because I still need to find my value for y. So I'm going to take what x equals and plug it back into my y equals equation. So y equals 2x minus 1. I'm replacing x with negative 1/2. 2 times negative 1/2, the 2's cancel. So y equals negative 1 minus 1, which is just negative 2. So my solution for this system of equations is at the point negative 1/2, negative 2. Alright, the next equation, or next method for solving systems of equations is elimination. What you want to do is line them up and eliminate values, and then substitute to find the missing value. So there's a good example right here. This one's a little more difficult, so I'm going to come back to that one. So first, this is the most basic elimination. They already have the same coefficients on y, and they're already lined up, x over x, y over y, constant over constant. So all I'm going to have to do, actually, is when I rewrite them over each other, since both my two y's are positive, I'm just going to subtract the second equation from the first. So going left to right, 4x minus 3x is just 1x. 2y minus 2y cancels. Bring down your equal sign. 8 minus 6 is 2. And then I can pick either equation and substitute that value for x back in. So I'll just go with the first one. So 4 times 2 plus 2y equals 8, and then I'm just solving for y. 4 times 2 is 8, plus 2y equals 8. Subtract 8 from both sides. Gives me 2y equals 0. And then divide both sides by 2. So I see that y equals 0. So my solution to this system is at the point 2, 0. Alright, let's go back to the more advanced one just for a second. The first thing we want to do is line up the variables. So this one, we see on this first equation, I have 3y on the right side with the constant. I want to move it over to the left side to be with the other variable, so I'm going to add 3y. So now I have 2x plus 3y equals 16, 5x minus 4y equals negative 6. They're lined up. Then you're going to figure out which one you want to eliminate. If they do not already match, you just need to make one of them match. So what they chose to do in this example was make 10, or turn the x's both into 10. So 2 times 5 is 10. Multiply this whole equation by 5. 5 times 2 is 10. But they wanted it to be opposite so they could just think adding. So they multiplied this whole equation by negative 2. Once they got there, they did the same steps we just did. You add straight down. 10x plus negative 10x, or 10x minus 10x, cancels. 15y plus 8y is 23y. Bring down your equal sign. And then 80 plus 12 is 92. Then you solve that equation just like we did. Divide both sides by 23. You get y equals 4. Once you have one value, you substitute it back into one of the equations to find the other value. And then you solve that equation and you have your solution. Alright, so now that we have reviewed solving systems, I want you to go to 10.3 in your books. So 10.3 starts on page 881. We are only going to start this section today. We will not finish it. Alright, so once you get to page 881, you should see the Explore It problem. For today, all I want you to do is part A with your partner. let's say you've got this system, this augmented matrix. I want you to answer part A based on those two figures. So I will give you about 1 minute to do that. If you need more time, you can pause for another minute or so. Okay, if you need another minute, go ahead and pause the video, but we're going to go ahead and go over this. So, describe the relationship between the system of linear equations and the augmented matrix. What does each number in the matrix represent? So, when I look at this, what I notice is that these numbers are all in the same position in the matrix. So, the coefficients and the constants in the system of equations correspond with the positions of the numbers, or let's say elements, in the augmented matrix. What do you think the vertical dashed lines represent? So looking at where they line up, the vertical dashed lines are in the same spot as the equal sign. So I can assume that the vertical dashed lines represent the equal signs in both equations. Alright, writing augmented matrices. So now we're going to write some of our own. Just like what we said in the Explore It. Your coefficients match position in the augmented matrix. Your constants on the other side of the equal sign match positions. Notice that these are already in standard form, the ax plus by equals c. They would have to get in standard form to be able to write the augmented matrix so that we have them in the correct positions. If we wanted to just have the coefficients, not have the constants or the equal signs, then we would use what's called a coefficient matrix. Alright, so in this example, 3x minus y equals 10, x plus y equals 6, we're going to write the augmented matrix. They are both already in standard form, so we don't have to change anything about that. So, my first equation, my coefficient on x is 3. My coefficient on y is negative 1. Equal sign, we use the 3 dots to represent, and then my constant is 10. On my second equation, my coefficient for x is the invisible 1. My coefficient for y is 1. 3 dots for equals, and our constant is 6. Alright, next example. So this one's a little different. You should notice that not only are there now 3 variables, there's 3 equations. So that means that this is now going to be a 3 by 4 matrix. But we still go x, y, z, and then the constant. So my first equation, my coefficient for x is 1. My coefficient for y is negative 1. My coefficient for z is 2. Equals my constant 2. On my second equation, my coefficient for x is 2. Coefficient for y is my invisible 1. There is no z, which means that my coefficient for z would be 0. And then that equals my constant 0. And then my third equation, my coefficient for x is 4. Y is negative 3. Z is invisible 1. Equals the constant 1. Alright, on your own, I want you to work on the self-assessment problems 1 and 2. When you finish, I'm going to give you about another minute of wait time. When you finish, I want you to check with your partner and make sure you're both on the same page. If you have any questions, once I've put up the solutions, then I need you to take about 30 seconds and get with somebody who feels like they're at a confidence level of 4 and have them teach you, so that maybe seeing it from a peer's point of view makes it easier. So work on the self-assessment for about a minute, and then I will come back on here and start writing the solution. Okay, make sure you have checked your answers. Take about 30 seconds, check with your partner, make sure they feel okay. If both partners are not comfortable, turn to a pair that is and have them teach you. Okay, if you need more time here, go ahead and pause. For today's practice, so we are done with notes, I want you to, on your own, complete review system /10.3 on Delta Math. So you will log in through Clever, open up Delta Math through Clever, and work on this assignment. The assignment is timed, so once you start, you must finish it. It's timed to give you enough time for the rest of class. It will match however much time you have after this video. But go ahead, work on the video or work on the Delta Math. If you finish the Delta Math early, then I want you to start on this homework, page 887, numbers 2 through 12 evens. On both the Delta Math and the homework, you should be working independently. If you have a question, you can ask a peer, but you should not be working in pairs for this. If your peer cannot help you, and you have watched the video and you have looked at the example on Delta Math, then you can ask the substitute, or you can go across the hall to Miss Harris, and if she has a minute, then you can see if she can help you real quick. Have a great day. I will see you guys next time.